Okay, in this example, we're going to look at applying rational equations by solving a work problem. A work problem is a very common type of question you might see on your ACT or an EOC. It basically involves one person doing some work and another person doing work, so if they do it together, how long should it take them? So in this case, we look at Cruz's shoveling in the family driveway, and it takes him 40 minutes, and his brother Roman can do their same driveway in 30 minutes. So how long would it take them to do it together? So thinking logically, like the fastest brother can do it in 30 minutes, so if the slower brother is helping him, your answer definitely has to be less than 30. So make sure when you get an answer, like it's sounding realistic. In order to do these, we're going to look at something called a work rate. So what I mean by that is Cruz's work rate is he can do one job in 40 minutes. That's his rate. Whereas Roman, his work rate would be one job is in 30 minutes. And so when I go to set up my rational equation, I'm going to have Cruz does a job and Roman could do the same job, but how long would it take them to do it together? So that one job, I don't know the time it takes them to do it together. Okay? So if we add their rates together, I don't know the actual time that it's going to take them. So that's why I have an X there. Now, this rational equation, we solve it like we do all the other ones. We find the LCM of the denominators, we look for excluded values, we're going to distribute to get rid of the fractions, and then we're going to solve and make sure we don't have anything extraneous. So if you want to find the LCM, we're going to have to break this down. Again, there's tons of ways to get the LCM of these values. This is just one of them. If you find another one on YouTube or something, go for it if you like it better. But I break them all down. And remember, we're looking for the product of the factors, and if we have any repeated factors, we take the greatest. So over here on the 40, I can see that I have 3 2's. So my LCM would be 2 to the third, because it's more that 2's on this side than it was for the 30. They tied with the 5. They each only had 5 to the first power. Nothing greater than that. There was a 3. And then over here, this guy, he's just an X. So my LCM, if I kind of multiply all those together, would be 120x. Excluded value would be 0. So if I get x equals 0, then I know that that will be an extraneous solution. So let's go over here and rewrite this, and we'll go through how we solve it. So I'm going to take my LCM to all the fractions, all the way across. So I'm going to take 1 times 120x over 40, 1 times 120x over 30, and then 1 times 120x over x. So I distribute that to every fraction. And my goal is that they will reduce. So 120 over 40, that will reduce to 3. And then there's an x. 120 over 30 is going to reduce to 4. And again, that one also has an x. The last fraction, notice the x's will reduce there, and I'm left with 120. So if I combine my like terms, I'm going to get 7x equals 120, and if I divide that out, I get 17.14 basically minutes. So we're looking at the fact that if they work together, it will take them about a little more than 17 minutes to get that completed, which seems realistic since Roman could just do it by himself in 30 minutes anyway. This is not equal to 0, so therefore it's not extraneous. It's a good